fireside chat with the man, the myth, the legend, Brian McClendon. We were just hearing a lot of discussion about, the democratization of 3D capture and also kind of that crazy mix. What has happened, let's say, over the past 5 to 7 years and the different technology trends that has kind of come to a head that's made all this possible?
I do think that there is something about being able to process the data on the phone because, think about it from a Polaroid camera perspective. Some of us are old enough to remember why Polaroids had a big advantage over film cameras, which was you take the picture and after waving it for about a minute, you get an idea, is this the picture? Did this capture exactly what I wanted? Am I excited or do I need to take another picture? And the same is true with, I think, Gaussian splats. The ability to give a visual feedback within a minute at the location you're at and say, yes, I've succeeded is pretty powerful. The other thing, and we've been very focused on the future of augmented reality glasses. And that it's still in the future from a scale perspective. But we've had mixed reality come out in full force with the Quest 3 and the Apple Vision Pro. This idea that you can do effectively augmented reality but with see-through cameras has made a sort of compelling use case for mixing the virtual and the real. To do collaborative AR/VR, you need some way to capture very quickly your environment, upload it, have somebody in a VR headset download it, and the two of you share a perfectly sixed-off correlated position between the two. That is a service that we're providing as part of our platform because we can do this very fast capture and upload. And we see this as, I think, changing how people interact with the real world.
How do you think about interoperability and innovation?
We created a new file format for Gaussian splats called SPZ that is about 10 times smaller and actually faster to render, and we open sourced it and gave it to the community, and we've seen it built into a lot of the existing Gaussian splat tools already. So we're very much into sharing and improving this, but I think it's very early, right? It's the challenge with standardization when you're early days is that you lock into a snapshot in technology that's the wrong one. Speaking of the OGC, KML was a file format that we built at Keyhole to allow you to put data on top of Keyhole, then Google Earth. We didn't bother to rename it GEML or whatever it was going to be with Google Earth. Left it at KML, and we ended up, after we got to about the KML2 standard version, giving it to OGC and working with OGC to make it an open standard so that everybody else would have interoperability. And one of the things that we also did as part of it was to create this libKML parser, this library that allowed anybody to parse it and be consistent. Because one of the challenges with any file format or data format is that if you just throw a speck over the wall, the interpretations, you end up, whoever was the 800-pound gorilla interprets it their way, and that's the only way. And so the hope is that if we can get not just standards but code open sourced, then I think we can all move much faster.
Awesome. So 3D capture, right? What's your vision, or how do you, if you're looking forward 5 years, how do you see that all coming together?
So I'll go back, 10 or 15 years. For those who worked with me at Google, and I spoke about it internally, who heard me talk about it externally, I used a phrase called bundle adjusting the world. And it is to, multi-sensor fusion, effectively. All sensors have opinions. Some of them are right. And if you combine them together, you can usually iron out the errors between them and have a more accurate view of the world. And I think that's going to happen even more now and much more quickly because we have these user sensors like the phones, but we also have these very high precision collects that are being done by many of the people in this room. And I think there's a very interesting transfer function between taking high quality ground truth, or the closest to truth that we have in Jack's phrasing, and comparing our lower quality sensors to it, and effectively figuring out, using not necessarily LLMs, but using some models to improve the quality of cheap sensors to improve towards the direction of the expensive ones. And what this means is that the seeded data of very high quality that some of you are capturing in some places will eventually inform the quality of data everywhere. And I think that's a superpower that is coming in the next 5 years.
Parting wisdom for some of us old people, parting wisdom for the young people in the room. Give them a McClendenism.
The big thing coming, is large models. And, language models are teaching us so much about, they don't just solve one problem. They're not just about, putting words in a row in a pretty way. There is, fundamental rearrangement of information, some of which is innovative and some of which is deeply confused. And we actually have, larger sections of data that are not yet run through this model, or any model. And yes, we're doing feature detection and extracting information. But at the end of the day, language models are running up against a wall, a huge wall, which is they've run out of information. All the good stuff that humans have ever created has been collected by these large language models, or purchased. Like Reddit has sold its data, and Shutterstock and whoever just merged, Getty just merged, for the sole purpose of being a input into some of these models. But human data is limited. But guess what? The world is not. And we're sitting here on the largest source of long-term collection of new data to train these models in some form. And for any area that's important, we can go collect more of it. And I think that we're going to see, what we call large geospatial models take over, because that data continues to change. And to Jack's point, everything in this world is changing. And we are, our eyes, our sensors are trying to observe that change. And the challenge for all of us has always been we have arguably too much data and not enough facts, not enough information. And the one thing these models are actually pretty good at is distilling and extracting information. And if we take all of our combined raw data and find the right models to extract the information, I think we're going to get a lot more truth out of these models.
Awesome. Thanks for the parting wisdom. Everybody, let's give Brian a warm round of applause.